All right, so for RStudio, if yours comes up like this, which is what our Justin is looking at, everybody else, you might have another pane in here. All right, so I'm gonna add one other little dimension. I'm just gonna say file, new R script, so I can make mine look somewhat like yours. So in this space is where you've got your visibility to look at your program code and also see data sets. All right, so in order to make this usable and understandable, let's take the first line from the
Before we
introduction.
proceed, I don't have any of that. I got this up, but I don't have those files on the side or none of that.
Yeah, you're okay. There's a little bit of variance.
Okay, so I just want to make sure I can follow along, but I just didn't know the percentage.
Yeah, so if you just did file, new.
New.
Yeah, and then R script, then you're gonna have identical to what I have, or close to it. I mean, the general layout will be identical. So.
Okay.
File.
So going to, so all I did was go file, new R script, and then I had this blank untitled window show up right here. Okay, so we've got these panels to work with, and you can go between the panels and make panels smaller or bigger to whatever your interest might be. For right now, we're going to be focusing on this lower panel with the console and seeing what happens in the environment window. All right, so these two that are kitty corner from each other is where attention will be. Yeah, the one in the upper left will be empty because we're not putting anything in there right now. We'll do something with that at the end of this introduction exercise from the UCLA tutorial. All right. So let's go to the UCLA tutorial. It's right here. Okay, so what we're doing is these 4 steps. This is what the tutorial covers. All right, one step at a time. Take this italicized line, copy it, and Alt-Tab is your way in Windows of going through various applications that are open. So if you just do Alt-Tab and go to RStudio, I want to paste that in on the console. So Control-V, paste it in. And then what this is doing is loading a data set from a particular location on the web. So it's going out to the web, that's HTTP, ://. So it's going out to this domain. At that domain, it's looking at a directory called Homeworks, and under Homeworks, it's pulling up this file. Okay, so this is literally what's happening. After this line executed, after this line executes, it takes this CSV file. CSV again is what? Right, comma separated version. Yeah, that's what the normal format is for exporting from Excel. Okay, so we read that file, that read CSV file, and we assign it. This is the assignment operator. We assign that file to this variable called ACS. So I walk through what this line does, and when that line executes, you see the variable showing up over here. So this says I've got a variable ACS, which came from the left-hand variable name that we gave after the assignment operator. And we see a little description of it. And there's this collapse expand icon here. So if you click that icon and maybe move this panel down a little bit, or move the border down a little bit. All right, you see how many columns, essentially. You see 14 columns. If you were to visualize this a little bit easier, just click once in here. Okay. I want to slide this down a little bit on the other side. All right, so you got a comparison now. Household, age of husband, age of wife, all the way through decade built. So household, age of husband, age of wife, all the way through decade built. You've got to scroll over there to see the right-hand side of the data set. So the integer is down on along the left margin. These are just your row numbers. So I'm looking at row 1 right here and row 2 underneath it, etc. Same as you'd see in Excel. Okay. So what I'm seeing is, and let me connect it, this is the visual of what you're looking at right now compared to the text. Let me go to the summary here. So 7,811, like OBS, what the heck is that? Okay, because R came from the land of statistics and statisticians, OBS means observations. Because that's the normal term that's used when statisticians do a study. They say, hey, I've got 5,000 observations, or 2,000, or in this case 7,811 observations. Okay, so these observations, each observation shows up as what over in the upper left?
Rows.
Yep. So if you were to scroll all the way to the bottom, you've got 7,811 rows, or it's observations is the term that's used here. Okay. And when it says 14 variables, what does variables refer to? Right, columns. So we got 14 columns called variables. That's what the term is in working with analytics. So the name of the variable is the name of the column. And each column is multi-valued. You've got multiple values, one data value for each row. So the same concept as working with a relational database table or working with Excel. No difference there. All right, so keep in mind you've got this expand collapse here. Okay, so let me show you stuff that can throw us off every now and then. Okay, so focusing on this global environment window, it is inadvertently, and it usually happens every other class, maybe a little more frequently. Somebody will accidentally, their finger will slip and they'll go boom, and then there'll be a packages. It's like, my environment doesn't look like yours anymore. And there's this little drop-down menu here. Right down here. That gives you global environment. You can go back to it, or you can look at a package within R. Okay, so the package, R has about 5,000, actually it's more than that. Utilitarian-wise, it has about 5,000 packages, but people throw packages together and put them out there, so the actual number is about 13,000 now. And the growth in R packages parallels to the market commercial acceptance of deploying Hadoop and using Hadoop. So as the packages for R have increased, it's exactly to the same level that Hadoop itself has increased. So just interesting observation. I'll put those graphs on the board later. All right, so don't get stuck in the packages. We will look at a couple of these packages later, but at this point, there's nothing necessary to care about or reason. These packages are basically showing you, like, and this is a stats package, they're showing you that, hey, I've got a bunch of functions here. And a bunch means a lot. Like 100 to 200 functions is pretty normal for a lot of these packages. So in other words, there's already been a lot of work created. If you're a project manager working with an data analyst type project, be suspicious if somebody says, oh, I'm writing these R functions. Like, should that already exist? Somebody already wrote that. Probability is really high. Just take a half hour and go look, okay? And at the end of our time together is when we cover those questions. How do you go look for packages? And you got like 13,000 of them, and each of these packages might have like 100 functions in them. So you're already up to like 130,000 functions. Okay, so there's a lot of rich created work already available. All right, so I'm going to flip my environment back to global. from packages to global. You'll find history tab right here. We've only typed in one command right now, and I clicked on ACS right here. When I clicked, and you probably also clicked on ACS, you'll find another command called view that got executed in order, this view parenthesis, ACS close parenthesis is what gave us the display in the upper left. All right, so getting the feel of this?
So no, none of this has worked the way that and I know I've been following here.
Okay,
So, I'm just following.
okay, so these three windows, I want you to click this stuff and go for it as well. So you got ACS, go to your environment tab here and click ACS. And there's your data
Okay,
set.
all right,
Okay.
all right.
So that's the only thing you're following. Just
Okay, I did.
You did that one little click there.
Okay, gotcha.
So that's normal to have to say, wait a minute, what did you do?
Well, that's good.
Because we're just getting used to this stuff. So okay, so let me go down in your console here. Maybe where we pasted in the command.
I did because you said do all the tab, and every time I did this one,
Right. So
you hit more.
yeah, don't worry about that. I got Alt Tab, but you got RStudio there. So just go to RStudio.
Which is over here, already.
Okay, so you have them side by side, which is even, if that works for you right now, that's
So
fine.
then I'm
This
pasting
is
it
pretty
down
narrow.
here.
This is right here. So control, copy, paste, and then return. And so after you paste into the console prompt in the lower left of RStudio, you have to hit return or enter key.
Return from there,
Yeah, hit the enter key.
oh, this one, here we go, just the great return.
Right. And then that ACS pops to visibility in your
Which
upper
is this
right.
here, and it should come up here.
Yep.
Which is here.
Yep, and then
Okay.
click once on that guy. And then you see that data set present. Okay. So we're all at the same place there now. Okay. All right, so as we walk through this, we're not gonna follow everything in here. If you don't have something simple like a CSV, you got something that's a little more custom, there's an import capability. So I skip past this, just scroll past it. Go to the transforming data section here. Okay, so grab this guy, copy ACS age husband, and we'll be running these other commands here that want to make
So
sure
that's
you're
on the Google page though, right?
correct on the Google page. So back at the introduction, will be a transforming data, ACS $age husband. So if I do Alt Tab, I'll immediately go to RStudio, and I can paste that in. Okay,
In the console?
we'll always be working in the console for this introduction here. All right, so question. When I paste that in, what is this referring to in square brackets?
Roll number.
Correct.
Yeah.
So very specifically what that means, this is row number 25, which means the data value in age of husband is 84 on row 25. So you can just scroll down a little bit, row 25, age of husband is 84. So that's right across here. Okay. So you and I are normally going to have different numbers in here. I've got to change my properties here to make this a little bit bigger. Let's see, this particular account, the preferences are not set. I only do this like very rarely, so let me just figure out where to do this. I think it's global options. That way you can see better from the back. So general code appearance. Okay, font size, I'll put it up to like, probably 14 right now, it might be too big, but we'll see. That's all right. And maybe bump it down just to, yeah, 14 is good. Say okay. All right, so I just changed my window sizes here. So when you're in the console, you can arrow up and arrow down. So this lower left window is your console. If I arrow up, I get the command that I just ran. And I run it again. Okay. All right, so now it says that I'm at row 1 and then row 18. Previously it was row 24 or 25, whichever it was. All right, so just to get used to seeing some variance and like you mentally accommodate for it, why is this saying row 18 instead of whatever was up here, row 24? Okay, I made my text bigger, which means I have less horizontal real estate in which to display data values. Okay.
Mhm.
So if you just took and changed your window to be like wider and run this again, how you're gonna get a different number,
Wow.
okay? Because this is set up to fill whatever your horizontal distance is across that console window. So don't get locked in on like, oh, my row 24 is not your row 24. By the way, where is your row 24? Because I don't see it in square braces anymore. Like, that's okay. You still have it in there. All right, so this is just some of getting used to the IDE environment. Okay, every IDE always has a console where the output of the commands will be visible. Okay, that's true for complex programming language environments as well as it is for this. Okay. All right, so this is age of husband. All right, so what does the $ indicate?
Is if in technology, sometimes that's a stop and go thing. Is that what's happening here?
Essentially, another way of referring to that is it's a dereference symbol. Okay, so ACS is what?
The data.
The data set.
Right, the data set. So we're going to dereference inside ACS. We're going to dereference to the age of husband, which is a column inside that data set. So other programming languages, including SQL, will say it's ACS dot age husband. You know, here in R and in Python, with pandas they call it, it's the name of the data set, $. Okay. So just being able to navigate into data sets and understand the syntax of how to do that is partly what the introduction shows us. All right, so if you go down to this, what's the square bracket showing?
Row and column.
Row and column. So 62. So we got row 1, column 3, 62. So for those that have got a programming background a little bit, it's like, okay, so do I reference the 1 or 0? It's always the annoying thing in every programming language. But R is referencing 1 as the starting point. It doesn't start with 0. So when it says 1 here, it means row 1, not row 2. Same with the column, it's row 3, not row 2. I'm sorry, column 3, not column 2. All right, so subset. Take that into your RStudio, paste it in there. All right, so subset is called what? And our read.csv, these are what?
Subsets.
Smaller portion.
Sorry, what was it you said in front?
A subset of the, like she said, a smaller portion of the data set.
Okay, true, but I'm trying to say, okay, read.csv and subset, what are they generically referred to as?
Mhm.
You gotta lock this in your mind, it's functions,
Oh,
Oh,
okay? Okay, so the format for every function is that you get the name of the function, no space after the name of the function.
Hmm.
And then you get your opening parenthesis. And inside you have the parameters for that function. The first parameter, if the function is designed well, the first parameter will always be the primary parameter. Okay. And then the secondary parameters usually adjust or apply to the primary parameter.
Hmm.
So you could have a list of 1, 2, 3, 4, however many additional parameters there are. But normally all of those parameters apply back to your primary parameter. So think of this as a primary followed by a list of secondaries. Okay, with a closed parenthesis in there, comma separated.
All the other extra parameters will be separated by a comma.
Correct. Mhm. Okay. And this is the assignment operator. You can put an equal sign in there, but for whatever reason, statisticians, and they did R and created language that said, hey, we'd like our assignment operator to be less than dash, 2 characters, as opposed to equal, which everybody else on the planet does. Okay, so I don't know why they chose that, but it's historically, that's the way it's been. You can type in equal if you're more comfortable with that, and that'll do the same thing.
Oh, okay.
It doesn't matter. Okay, so because somebody, who's from the general world of programming said, you guys are crazy, I'm not used to doing that. So I want to make it equal. So it's open source software. You write a little adapter module into the R language, and now R supports equal sign. It's just the way open source works. And it conforms to what the current demand is or current preferences are. All right, so we're just getting used to some syntax right now, okay, and some terminology. All right, so now you have a bunch of other functions down here. You got the mean, the median, quantile, variance, standard deviation. That's what all these are. You usually don't run all of these because you can do that on your own, and by the time it's taken me to explain a few things, you've already run it anyway. At the bottom, there's also summary ACS. I'll just grab this one. And summary ACS goes through and let me scroll up and I'll move this over a little bit. One more time. Okay. So summary ACS is showing, I think it almost all fits on here. There we go. Okay, it's showing household, age of husband, age of wife, etc. All right, so these initial variables, I use that word variables instead of columns, so you kind of get used to hearing that. So it's columns or variables, those are interchangeable terms. Okay, it's going to show a statistical summary of the data values under the household column. All right, now the household column doesn't mean anything though. Right, because this is just an ID internally to identify which observation we're talking about. So it's like, yeah, okay, so I see this, it doesn't mean anything. All right, now age of husband, age of wife, that means something. Okay, so the minimum age in that, meaning the smallest data value in that column is 17 and 19 respectively, and 95 and 95 respectively. Okay, so what is median?
The
Average.
midpoint. No, the median, like what's the middle number in between that data set?
Right, so the middle number between 17 and 95 is 55. So meaning that 50% of the numbers are bigger than 55 and 50% are smaller than 55. So I'm saying that from a general, common sense, pragmatic perspective. If you look into details, it's like, well, what if it's an even number of divisions and, it's like, okay, so don't worry about the details, okay? Wikipedia is a good source for getting into the details and variances of what median technically might be when you have an even number of data values versus an odd number of data values and things like that. Okay, so the mean is what?
Average.
Right, the average. So mean is always average, median is 50% mark in terms of number, the quantity of data values being larger than this and the quantity being less than that. All right, so first quartile, what does that mean?
Isn't that on that like statistical?
The bell curve.
Yep, that
The
bell curve.
Yeah.
Mhm. Okay, so let me put this on the whiteboard quickly just so we can see this, partly because it maps into our language statistics that we're getting into, so we can start tying this together a little bit. We're not going to do a deep dive into this, but just do a quick sketch. Make sure that goes in the whiteboard, and we got to keep our studio visible. So just take one of these ages here. I guess I got enough room over here to do it. Go some black here. Okay. All right, so we take a normal bell curve like this. Okay, the mean, or actually this is the median. I intended to draw this through the middle, so roughly it should be in the middle. So the median we said was 55 from that column. And what's your min value?
7. Well, for husband or wife.
That we can, whichever one was it
17 for
husband? Okay, so we'll do the husband one. I didn't remember which was which. And then both of them had the same max value, 95.
yeah.
Okay, now quartile refers to kind of this portion here and this portion here. Let's see, this is a bell curve. That was really bad. Let me just fix that so they look better. Let's see, going through here and up through there. Okay. All right. So I've got my first quartile. The median is actually my second quartile. And this is my third quartile right here. So quartile just means similar to what we just said for median. First quartile is all the data values from 17 up through 25% of the data values.
Okay.
Because median is, we said, all the way up through what quantity of data values?
55 or 50, yeah.
Right, so 55 is the data value, and that means that 50% of the data values are less than 55, 50% are more than 55. And the important thing to know for a quartile is that it actually does include all of what I'm drawing over here. So it's all the data values up to that point. So it's not just, when we talk about like, hey, new baby born, child grows, okay, what percentile are they? 98 percentile or 30 percentile or whatever. So that's the language and the speak that we have with the doctor. And in our minds, we always say, oh, they're at the 30, say the 60 percentile. Okay, so we always think of that as an absolute line. And quartiles and technically percentiles as well is like, that's everything, all inclusive, up through 60%. So that's just a little rewiring we've got to do in our thinking there to be able to keep our common speak separate from the statistical definition. All right, so bell-shaped curve here. The other observation to have across here is that what axis has the data values? And then this is kind of obvious, but what axis, y or x-axis, has the data values?
X is age.
Say again?
X is age.
Axis.
X-axis is age.
Yeah, yep. Your voice got a little softer, so I didn't quite hear the tail end. All right, so your x-axis is the data values. And in this case, the data values are age. Okay, so what's the y-axis?
Frequency.
Yeah, frequency, meaning count. Okay, so I have a count, and we can get the actual data values out of here. Sorry, the pen that I grabbed isn't very good. Relative to however we want to mark this with some tick marks. We can see what the quantities are here in a moment, but frequency or else a decimal representation of percentage is what will always be on the y-axis. Okay, so the image I want you to come away with as just a first impression of statistics is that this graph describes one variable. So that's the image I want stamped in your mind. Okay, because this is a distribution curve for one variable. Let's see, let me go with this.
You need to raise your house.
All right, so distribution curve. A distribution curve always describes the data values in one variable. Okay. And we'll be touching on that later on as we go. All right, going back to where we're at over here, share this again. All right, so as we walk through this, these are numeric data values under these columns. So what do you see when you get to mode, for example, or internet? Now we don't have numeric data values. We have what's referred to as categorical data values. So under mode, you see the values follow-up, internet, and mail. And if you go look at your environment under ACS, it'll indicate to you down here that internet is a factor 2. Mode is a factor 3. So this is, again, statistician speak. Okay, factor just means it's a label. It's not a number, it's just a label. Okay, so factor means label here. And then when it says levels, levels just means how many unique data values are there for that particular column. So it's just no or yes for internet, and it's follow-up, internet, and mail for mode. All right, so just getting acclimated to what is in a data set, how do we start playing with this? It's really simple with categorical variables, just a count of each of the data values. All right, let's slide that back over. All right, so I have a summary ACS. Go down here a little bit more under plotting. So, and by the way, I didn't bother looking at A, but if we had, let me just go back to A before we move away too quickly. All right, so. Let's go put that here. All right, so A has 5,139 observations in it. And if you look at the history, we created A by using this command. So what would be the command for creating B that would be the remaining amount of rows? So looking at this one, if I wanted to send this over to the console, I can just use this to console, select it, and over here, I can arrow over and I can edit. So arrow left, arrow right. If I subset it according to age of husband greater than age of wife, how would you change this to get the remaining? And I'll call this B. You just change the conditional operator, less than or equal to. Look at B as it shows up in the environment here. Let me close this off. All right, so you got quick calculator capabilities at the console as well. So 5139 plus 2672. Right, so I've got 7,811, which is the total observations. I just split it according to the comparison of age of the husband versus wife. All right, so this is the thing to start getting used to, is that there's a lot of generosity in how these conditional comparisons can be made. And what have I actually done in terms of lines of code? I've only done a little line of code here, little line of code here, little line of code here. So I don't have to write any looping constructs to go through the data set. This is what makes the data set processing dramatically different from traditional programming languages, is that these functions know, oh, this is a data set. Obviously, I have to loop through everything here because that's what the data engineer wants me to do. So you never have to use a data engineer, or as a data analyst, never have to write the looping constructs. They're automatically in play. So this is what makes, and when I mentioned Big Latin, in LinkedIn, it took like 15 to 20 lines of code to come up with the entire people you may want to connect to list. They run that every night. It's only about 15 lines of code, because all of the parsing of working through the data set is automatically taken care of behind the scenes.
Can you run through how you got the V again?
So right here,
Yeah.
so contrast these two next to each other. We go to the history. Okay, so the B here, you just take the greater than sign and flip it to its opposite cousin and say less than. But since this one did not include ages of husband and wife equal to each other, you gotta include it somewhere to get the total number of rows back again.
I thought I did the same thing that you did. It didn't, it says error, unexpected.
Oh, by the way, whenever it does say error, speak up, because I will guarantee everyone, including me, will occasionally run into some errors where there'll be incomplete syntax or something like that.
Which
So-
I got, yeah.
So when that happens, speak up, because those are quick learning opportunities. So you can see how the IDE environment
Yeah,
works.
I was trying to see how to get out of them.
So I'll duplicate what you got in here.
Oh, you know what, maybe I had. Second.
Look over your shoulder so I can get my eyes onto your screen here.
There's two of those.
Okay,
There's
right.
only one.
Right, so what it looks like, what Maren did over there was unintentionally going like this. Copy, paste. Lining up with something like that.
Okay.
Yeah, so this is where you don't want to copy and paste in your console,
Not in there.
right?
Right.
You want to just arrow up and then arrow left, arrow right, and you can make changes on
You can
that.
edit.
Exactly, this is a line editor.
Okay.
So use arrow up, arrow down, or else go to history. And within history, you can search for whatever you want. It's like we put in, let me take one that's like view. Okay, so I can type in view. Start typing that in, and it'll take my search criteria and filter it against what's in the history. So you can always find quickly whatever you want. All right, so this is your efficiency tool over here, efficiency panel. Okay, well, I have another
So I
item
can
machine
change
counter.
any history as opposed to. Because that's what I was looking at, because once in environment, I didn't get it any further as far as this here, because I know each of these reference this frame. But at this point, after I went from there to try to pull in the other one, I wasn't getting something, so I went in to do the household, but it wouldn't go here.
Mhm.
So I knew I did something wrong, but I didn't know. So I was just letting you finish, and
Okay.
I was gonna ask you later.
So you're talking
So,
about getting
I
B in
even
there or
tried to
something
get
else?
this out, but I can't remove this from here. I have to do what history we were saying, do
Right.
arrow up and arrow down.
Right, so the council will always include an exact record of correct lines entered and incorrect lines entered. That's a scrollable, and if I remember right, it's searchable also. I usually do Control F, and that's your general keystroke to be able to open up on a browser, or Word, or any.
Because this is where I had the problem right here. This equal and this equal. Because you had said something equal, but I ended up getting it over here instead of going here.
Mhm.
And so that's where I got this error.
Yeah, so that's
Make
just,
sense or?
yeah, it does.
Yeah,
It
okay.
is. So what Luella was showing me over there was that, and we get down to this point. If you put incomplete statements in here, like this, or if you just say, C equals, and maybe put the function name wrong, like subset, DI, whatever. And so you'll always be getting, the whole purpose of the console, which is this left panel here, is to provide a place where it can tell you, I don't understand what you just told me.
Mhm.
So it'll give you error messages indicating, I don't understand. So,
But you back out of that error,
so you don't have to back out of this
don't worry
error,
about it in the console section.
right? Because in here, it's supposed to take whatever you type.
Okay.
So when we're copying from the webpage at UCLA, you take everything on that line.
Correct,
Okay, everything on that line and put it at the cursor
Mhm.
and hit enter.
correct. So at the cursor, you want to be able to change that just slightly and say at the prompt.
Okay,
So yeah, the greater than sign right here that I highlighted is referred to as a prompt.
okay, fine, all right, okay.
Okay, so let's see. All right, so that was the A/B thing. All right, now plotting data. If you grab this command here and plot it,
Okay,
let's see. Let me see what's going on here. Oh, it's doing things wrong intentionally. So, oh wait, that's right. Okay, I always get thrown by this at first. Okay, so this is a tutorial, and it's intended that this line be incorrect. This always
oh, is that right?
right.
I
So
will say, what did I do now?
right. And this throws me every time. I mean, I've taught this class like more than 20 times, and still every time I do this, it's like, what happened? Oh, that's right. It was intentional. All right, so this is trying to say, what's wrong in that line of code. Go look at it. This S doesn't exist. S is not in my environment. My
Which S?
environment is
The S before the dollar sign?
right.
Okay,
So what's supposed to be here? Not the S, but what?
what was there in the last one? I don't know, I don't remember.
This is the
So look up in your data area. So these are the only three choices there are. And this helps get our minds focused on how the IDE works. So my choices are A, ACS, or B. S is not up here in my global environment data area,
Mhm.
so I can't use S.
Okay, so ACS, well, actually, you can use ACSA.
It should be ACS.
It should be.
Right. So you just go in there and arrow left and type in AC.
Okay,
And then hit return or enter. If I say return, that always means the enter key. I tend to, for whatever reason, maybe keyboards used to have an enter in them. We got in a habit of saying that. All right, so then you get a plot here, and there's various additional plots you can do. And we'll see that this winds up just being a set of plots, one after the other. So this is a scatter plot, scatter diagram. Scatter plots, scatter diagram, those are synonyms to each other. So we're taking the age of the husband relative to the age of the wife, and you could put a trend line between these. And given the age of the husband, you could then calculate the age of the wife, relative to the within correlation of what would be relevant. It won't always work out perfectly, but generally it would be true.
So I'm doing something wrong here because I'm still getting an error. Am I allowing too many spaces or something like that?
Okay, so let me take a look here. And by the way, this is the purpose of this first segment.
Or
Is
am I
getting
putting,
used to our studio and its nuances and the way it wants you to interact with it, because you don't have a lot of choice over how to interact with it. You gotta figure out and see how it wants you to interact.
Right.
Yep. And then arrow over.
oh, what's I supposed to do?
You got two of them you gotta change, so just
Oh,
arrow
both
up.
of them. Okay, so let's do it this way then.
Or you could just arrow up as well.
All right. So
So you,
let's see. So I'm changing both of them.
Right. so there's two occurrences that are wrong in that tutorial that are intentionally wrong.
Alright.
So you hit the enter key and then your plot.
Okay,
So,
gotcha.
Mine is saying figure margin's too large.
okay, so that will happen occasionally. So when the set comes back with an error message saying figure margins too large, what that means is your plot window needs to be made bigger.
Just realized that's what it was telling me. And then,
So just arrow up. Don't copy and paste, just arrow up.
ah,
You don't want to get used to not using your mouse when you're in the console. No console actually generally works with the mouse. If it does, it's coincidental. It's not intentional.
Okay.
Okay, like you were able to click into a particular spot in the line,
Mhm.
and that's nice, but it's not always going to be the case on
Is that
most,
right?
on
Okay.
most console type line editors.
So there obviously are hotkeys for doing this.
Hotkeys and just arrow keys.
Is that right?
Yep, that's the way the line editors are designed.
I didn't know, because after we got this first error, you were saying to correct something.
Right, so arrow up.
So is it this arrow that we're dealing with or this one?
It doesn't matter depending on what you're downloading, it is on conflict, so.
Is it on? Okay, that's- So now,
The nice
what am I
thing is when I
changing?
started
So
the
arrow up
there were no
first.
IDs.
Well,
We had to figure it out on paper.
Okay,
Line by line.
now you're changing the $$ to, go over
So
here
this
and
dollar sign here?
go over to your
Let's come
total
over here,
environment.
can you, this is a lot nicer.
Click in your
I don't
environment.
know.
think to
I'm
myself,
not
okay,
getting
now,
to
yeah,
these two.
Right, so that means these are
now I
your
got
only two
pieces.
choices.
Right.
So you can't use S because S isn't over here.
Well,
You can only use ACS.
That
I'm a
happened
kid
here.
problem, so, you know,
Oh,
This
you're
I'm doing
error,
this way,
error here.
we're all
I
school,
wasn't getting
so
the other options.
doing different.
Yeah,
Or was I
you're fine. So there's only
Every
big
now
now,
and
you
then,
don't have
my
an error.
daughter's now
So
she's
it's only
in
one
London,
small line.
my son's
So let's focus on the
everywhere,
plotting here.
so I don't
So
have
go to that line.
that distraction with inside my
Right.
family. So I
And
tried to
change
scale
where
it
it
down.
says S dollar sign, change that to ACS dollar sign.
ACS dollar sign?
I'm getting to that point.
It's ACS is the name of the data set.
What's your daughter doing in London?
She was
ACS?
finishing,
Correct, exactly right there.
Which,
an
okay,
LL
okay,
in
okay.
designation, it's like a master.
And then make,
Okay.
and then make that same change over here.
Oh,
where-
okay,
on the line.
okay. Because it's referencing this here,
Exactly.
okay,
She's
environment.
doing international law.
Okay.
Yeah.
Wow.
So,
And then,
And then hit enter now.
and
Do
in
it there, or do I put the?
You just hit enter.
outside of the United States, if you practice law, it's
Okay.
really common.
Then you can zoom on that if you want to.
Oh, okay.
Good.
You know, it's not required.
yeah, you said we need to try and
She's
add a trend line or
She's gonna
something.
sit for the bar.
We're gonna do that.
We'll do that on other data sets later on, where we do the more statistical profiling of what's going on.
Now, within the
Well,
frame
somebody
where
who's
you have
practicing
environment
international
history
law.
connections, I only have
International
ACS, are those only two I'm supposed to have? Because you
Yeah.
put one there.
Right, so if you wanted to get the balance of the data set, you could do this B subset.
So I understand what I did not do correctly to get it in there.
Right, so here's the other
Is that
one.
the summary?
This we just took and edited the line that said A. So let me go up here, let me do it this way. So we had this in here at one point, and I'm using this to council here, so I can move the highlighted line over to the council in the lower left. If you change the greater than sign to less than or equal to, and just so I don't overwrite A, you change that to B. And that's what we had done to create this data set B. So we got 3 data sets, and depending on what work may have been done in your RStudio by other people prior to you bringing it up today, you may have other data sets, you may have other information over here on the upper right-hand side. Okay, so if it's there, don't worry about it, it's noise. Okay. Okay, so this is your scatter plot, and you go down a little bit further. You know, this is a cheap version of a histogram, because it's like, why would you use a histogram for this? Okay, but there's a couple things in here, histogram, table, and bar plot here. All right, so I'm just grabbing histogram at the top, so we can see what we're wanting to have available. All right, so histogram, number of children in the household. Okay, this is a histogram where here's 1 child, here's 2 children, here's 3 children, 4, etc. It goes out like this. So histograms aren't very interesting when there's a very small range of data values. They're actually very boring, not very useful. So what would be more interesting is to do a histogram of, say, the age of the wife or the age of the husband, doesn't matter which you pick. Let's say age of the wife. Okay, now you get a more conventional definition and abstraction of data values, because the age of the wife is now collapsed into a smaller representation. All right, so what do we mean by smaller? All right, so we see data values from 20 to 80 right here. Right, so split this in half. Here's 20, 25, 30, 35, 40. Right, so this is the nature of a histogram. It bins, that's the word bins, B-I-N-S. It bins together consecutive data values so that you have the same width. In this case, the width is 5. So you have the same width in each bin.
Okay.
So that's what a histogram is.
Is it fair to say that, I mean, possible rather, that you could almost find some of this information on a lot of different subjects and come up with the same kind of?
Oh, yeah.
Really?
Yeah, so this is just typical, what we'll see is a term called descriptive statistics. So the field of statistics at a high level just has 2 branches. One is descriptive statistics, the other is inferential statistics, meaning you make inferences from your studies about whatever your topic is, but you're going to infer from the sample to the population, the total population. As it's get into this concept of samples and population, and inference is what's used to make that jump from your, carefully controlled experiment, if you will, where you're looking at the sample and the statistics. You make the jump into, well, if it's true that the age of women, and this would be interesting to do here if I had some more data, but the age of the women are 70, and 1/3 of the homeowners who are women are widows. Do some correlations like that. If that's what the sample says, is that going to be true in every metropolitan area and the rural, or how does that vary from place to place?
So with statisticians and people who are doing informational research, like my kid's one was working on a dissertation, would she be able to go to this and look at it for a a reliable source like that, or is it just gonna give you ballpark kind of stuff?
Well, our studio will always give you your diagnostic capabilities, but the quality of the data set for your, is that son or daughter?
Well, that's their mother.
Oh, the mother, all right, like in the studies that you're talking about,
Mhm.
if the quality of the data set is good, meaning the numbers are accurate
Mhm.
and realistic to the sample, then you can take and crunch all of that through our studio and do whatever level of manipulation you want to apply,
Wow.
either statistically or graphically, whatever you want. Okay, so Python works the same way,
Okay.
only there's an additional library in Python that you've got to include to be able to do the graphing. But Python is very rich, premier data analytics environment.
Free as well.
Python's free and R is free. Those are the two main environments in which analytics are performed on raw data sets. Even you can do that independent of Hadoop. You know, we're not tied to Hadoop at all with what we're doing right now. Our focus here is, you know, what do people do when they do analytics? What does analytics mean? So you got to be able to visualize the data. So graphs are a way of visualizing the data. It'd be really cool when we get to the last lab, because then we're visualizing these models. Okay.
Now, question, based on the models and where they're displayed,
Or data sets.
the-
What are your,
is there a way to actually go in and do you worry about trying to edit the labels as they're displayed?
Nope.
Or you deal with what comes up the way it comes up?
you deal with it the way it comes up.
Okay,
That's true with every data set that you ever take in.
okay.
Now, you can make changes to it, like if, you know, it's like, that person screwed up when they labeled it. I want a different label that's meaningful to me.
Right,
You can go in and the best way to do it is copy the data set and then change the labels to whatever you want it to be.
but don't try to change the labels within.
Right,
You probably can't change
in
it
R. Okay,
because ours pulling from whatever the data set is.
Or,
yeah, but we pull a copy of what the data set is, so within the copy, you can actually go change it,
In R.
right, in R.
Oh.
So R gives you total control over the labeling of the columns and other, at this point, let me just say other aspects of working with the data sets. Okay, so it's a very rich environment. Okay,
Can this interface with databases, like pull data straight from a database or just?
Yeah.
Okay.
yeah, there's R packages that allow you to connect with any database like SQL Server, or Oracle, or whatever. And you could just say, give me this table of data. You know, and so you need the connector package to hit the database, to have a session established to the database. You'd also need, there's a package called Doppler from R that allows you to do like joins, left joins, right joins, outer joins on data sets. So typical operations that you do in data sets in SQL, you can do in R or Python or Spark. So this is what I mean by generalizing. And as we walk through this, you'll see that materialize as we go. All right, so I did a histogram of the age of the wife, because it's a lot better than doing a histogram of the number of children, because, you know, here at least the data values get the width from 40 to 45. Technically, this is from 40 to 44, and then this line starts 45 to 49. So I say this precisely. Now, in your plot area, we've been doing a couple plots, right? So you just have this previous next indicator. So you can use previous next and go look at your plots, see what you got.
okay.
From a help perspective, we've used this function called hist for getting histograms.
Mhm.
So if you go under help and type hist, HIST, Now, this is all of what you can do with the function called hist. And over here, we're seeing that we just pass in one column of data. But hist allows you to identify breaks, frequency, probability, which do you want, frequency perspective or probability perspective. There's various other parameters in here that can be set. So this is true with every function, meaning that I didn't need to set anything. I just gave it a column here, which is the age of life. I put this column in here, and all of these other things, I don't care about. They default to some value it's going to be applied onto that column. If I wanted my number of histograms to be something different, and I gotta look at this to see where it is. English breaks. Just see if I can remember this without thinking about it too heavily. It's not coming to my mind quickly. I thought I could just get breaks. Looks like 10. There we go. So, I don't know if breaks was in there easily. It said breaks equals Sturges. It's like, that's what was throwing me off a little bit. I could have sworn breaks was supposed to take a number, not a label. Normally when you look at any help page though, the best thing to do is always go to the bottom, look at the examples. Because usually you can recognize information in here if you're already a little bit savvy with what's going on. You can recognize, okay, that's what I want. The border equals purple, whatever. Okay. So if I wanted my breaks to be 10, I know it defaults to 20, so I chose 10 as an obvious number here. Because the previous plot gave me 20 of these bars. So when I say breaks equal 10, that gives me 10 bars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-ish. Depends on, kind of depends on the number of data values that are there. Okay, so that's walking through RStudio. So any questions at this point? Let me make sure I've covered sufficiently what's in the introduction.
So RStudio would be this console basically, right?
RStudio would be this window,
The window rather.
and the window has 4 panels in it.
Right, okay,
One of the panels is console.
okay.
Yep, so RStudio is this entire collection of panels. I did not go over these little controls, but I was using them while you were looking at them. So if I wanted to see this upper panel where I did have an empty file right now, I can use these little icons in the upper right of each panel
Mhm.
to reduce my height or close it completely or bring it up halfway. You know, if I wanted to take everything that I have typed in from the history and move it over to a source file and actually save it as executable script code later on. See, let me make sure I'm in history. All right, I typed something in there and let me turn it off, go back up. Right, so I could go through here and say, you know what, I want this range of lines from the history, and I'm gonna send that to source instead of console.
Okay,
To source means it goes over here where I can save it as a script file later on that I can run.
and you can come off and save it from outside from there, right? Meaning like if you wanted to save it to another data sheet or some other kind of medium, you can do that using the same function.
So basically.
Yeah.
So it depends on what the medium is, because the medium, sometimes you programmatically have to get to it through a function name in here, like save to.
Okay.
Or copy and paste will work sometimes. Here you've got a publish capability on the plot window as well. So I don't go into publish, but you're gonna see this R markdown
Mhm.
get generated. So the word markdown is a common expression in the land of websites and web development. A typical markdown file, and I'm not gonna go and install these right now because I don't know how long it takes to do this. I don't remember how long it takes to do these. But and let me flip this to the whiteboard. I've got one little corner I can use on the whiteboard here. Sure the camera goes to the whiteboard. Good. Okay. Okay, so if we're talking about, like a commercial environment, okay, you've got an R package. There's several of these. You saw from that quick window on my screen that there were several different R packages that would need to be downloaded to generate the R markdown. That would be that plot. Okay, so you have R packages for websites, which there's like a dozen packages, I'll say plural here.
Mhm.
So website presentation, so whether presentation of data, you can add functions into it as well. So you get a bunch of packages here. One of those packages is called R Shiny. And there's the concept of this R markdown. Okay, so markdown, just from a concept perspective, is if I have a text markdown file, text markdown file is really the ultra simple one, just uses hash marks. So this would be my main section. And then there's going to be some lines of text, whatever I want to display on the website or in the document. If I do double hash sign, that's a subsection
Mhm.
within the section.
Okay.
And then I have more text, and I can do hash, 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 whatever depth you want of subsections.
Mhm.
But the whole point is that the count of hash marks is your depth, whether you're at the top section or in some nested subsection.
Mhm.
All right, so that's the basic concept of a markdown file. It's ultra simple in its formatting. Now, if we publish an R markdown file of that plot, it'll have a lot more complexity to it.
Mhm.
It's not going to be as simple as just a few hash signs here and there. But the idea is that the R markdown file gets, you go from RStudio, you generate this R markdown file. That R markdown file can sit within some JavaScript-based website that uses R Shiny. So this website here can take in that markdown file.
So if you're using this to work on something personal, and in so much as you're extracting or drawing data off a repository from whatever, because once you put it in, you get a return.
Mhm.
If you're working on something, is it as accessible to other users as the information you're getting from to draw, if you understand what I'm asking?
So let me say from a general perspective, yes,
Okay.
but there's always the security and access. So as long as everybody has the appropriate login,
Okay.
Right. You can, if this is somewhat sensitive information, either with personal information in it or whatever, from people that are accessing your websites, there would usually be some type of credentials that have to be authorized,
Okay, to get in.
username,
Okay.
password to get in.
Right.
So the R Shiny, this idea of R markdown,
Mhm.
that's just the data in the back end. Whatever authentication you want to put on the front end,
Mhm.
that's up to the business policies that are appropriate for the organization. All right, so we've got our field into there, our field of our studio. So let me just go back to sharing the screen here. So I'm gonna say no here because I don't want to install more packages right now. At this point, I believe we've gone through everything we need to on the tutorial. Let me scroll down here. All right, so counts, we saw this already. I'll just take these last ones and for completeness sake, just pop them in here. All right, so counts came up, it's in my environment. It comes up as a value because it's not a data set. So things that are not data sets show up under here. Okay, things that are data sets show up under the word data. All right, so if I were to just type the word counts, it'll do a dump of its contents. So I don't have to say like print counts. I can just say counts and it shows. Okay, and this is the number of bedrooms. So this is the number of households that have no bedroom, have 1 bedroom, 2 bedroom, and some house has 10 bedrooms. Okay, so there's actually 72 households that have 10 bedrooms. So for whatever reason they did that. Okay, must have been some ultra rich area next to the standard working people like us.
I'm still dealing with the house with no bedrooms.
So many rooms to clean.
Yeah, that'd be my impression too. That's too big. We got a 3-bedroom house. We have 2 daughters. They're all married right now. But that's always been fine for us. Yeah, this is probably the what do you call it, the efficiency department. All right, so counts is, and even with plots, let me go back up to here where we saw the histogram. So this generated a plot. I can say histogram for the age of y equals that. And then if I were to get the histogram, but this is the way it's storing the representation in the histogram. Okay, so even the plots themselves can be programmatically examined. You know, we visually need to see it for obvious reasons because we relate to visual. But if you have a data engineer who wants to generate some plots and store the plot and then just go look at the plots with using program code to look at the plots, perfectly fine. Okay. So that this is similar, and I'm showing this because this would be similar in concept to what would be in the R Markdown file. It would summarize the visual plot in some meaningful manner that could be properly interpreted. Okay. All right, so that was values. Bar plot. What was the other guy? Yeah, so just distribution of bedrooms. Kind of interesting, but you know, it just shows you got another plot. Okay. So with that said, let's do a quick break here. We got done with this segment, and I would like us to, after the quick break, we'll go into getting acquainted with R here. Okay, so we'll stay on this R theme and get used to it a bit. And this is a little bit more hands-on at the detail, working at the console. Okay, what am I doing exactly? How do I use the language? Okay, so we'll do that, and that'll take us up to 5 o'clock. Okay, we may not get all the way through this, but that's okay. We'll just start off with it within the first part of the morning, maybe not immediately, but the first part of the morning when we get together next Saturday. So take another break.